Hi, today I'm going to show you how you can quickly calibrate the COMSOL extended tube model to some experimental data that I have for the rubber. So in this case, I have experimental data in uniaxial tension, biaxial tension, and planar tension. And I want to calibrate a good hyperelastic model to this data set. And in COMSOL, there is a good hyperelastic model that is available for cases where you have experimental data in many different loading modes, in this case 3. And that's the extended tube model. And it works really well, and it's a high accuracy model that is very useful for these kinds of materials. So what we're going to show here is how you can quickly calibrate this model and use it in your COMSOL simulation. So the first step is to simply read in the experimental data into calibration, which I already done here. And then the second step is to select the extended tube model in the list here. So I go to COMSOL, hyperelastic, and I select extended tube model from the options under hyperelastic models. I click OK. And then what happens is calibration selects default guesses for these parameters. And I'm going to add one more load case here because I want to search for the bulk modulus to get a specific Poisson's ratio in this case. So I'm going to click on the plus sign. I'm going to add a Poisson's ratio load case. I'm going to just call it PR. And I want the Poisson's ratio in my example to be 0.45. Why not? It's a relatively simple value to use. You can pick whatever you like if that's not to your liking. I'm going to activate that to be searched for. I'm going to provide a slightly better guess for it. I'm going to then run once, and we'll see that the initial guess that calibration came up with had an error of about 9%, but it's a good enough guess to start with. So I'm going to start the calibration by clicking Run Calibration. I'm going to use the extensive automatic method and then say OK. At this point, the calibration will be fully automatic, and it will search for the parameters to give you the best possible fit to the experimental data. So it's going to let it to sit here for a few seconds while it optimizes these parameters. We see that this particular material model matches the 3 loading modes very well. It matches exactly the Poisson's ratio that I specified. This is the model that I want to use. It's a robust, good model for this particular material. So I'm now going to export this so I can put it into COMSOL. There are 2 different formats to use here. One is a text file and one is a Java file. I'm going to demonstrate the TXT text file option today. I'm going to save it as a text file. I'm going to save it right here. I'm going to call it material parameters TXT. Then we'll try to open this file. So we got the file. It looks like this, and it lists the parameters of this calibrated material model. These are the values that we'll plug into COMSOL. So just to demonstrate that, I'm going to open up a window of COMSOL here. I have an example file. It happened to have a different material model in it, so I'm just going to add, I'm going to deactivate this one. And I'm going to add my calibrated material model. I'm going to pick extended tube model. And I'm going to specify the parameters that we found from our calibration in calibration. So I'm just going to copy those values over one by one. I'm going to move this window over, and I'm just going to copy it one by one. And here it is. Now I can run this COMSOL simulation as I usually would. And that's how you would take a material model from calibration and plug it in very quickly, in this case, into your simulation of whatever product you're interested in. As expected, the simulation ran just fine, and we're good to go and simulate whatever products or procedures that we're interested in. And that's all there is to it.